But this morning, don't worry, we're not going to talk about machine learning specifically. We're not going to talk about algorithms and neural networks and all that crazy stuff. My purpose today is to discuss how you can scale machine learning workloads. So if you're a DevOps engineer, or if you're a machine learning engineer in charge of deploying machine learning to production, what are your options? What are the different steps you can take? Because scaling machine learning is really not different from scaling anything else, right? I mean, people make a big deal out of machine learning, but it's just like software. So in my experience, sometimes, you have, I would say, linear scaling, and it's fine, and you can keep doing what you're doing, just add a few more resources, and every now and then there's a big jump, okay? There's a big jump in scalability, and you need to do it differently, okay? So that's what I'm going to discuss today, how to start and how to keep scaling using different techniques. So initially, of course, I'm guessing a lot of people start at day one with machine learning, and it's just one user, it's you, right? Trying to get things done, trying to move a first model to production. So usually it will start like this, right? You or someone in your team has trained a model, a first model based on data, and it works on your local machine, and you use probably open source to do it. And you tested the model, it's working, it's okay, you're happy with it, and of course now you would like to deploy it to production. Okay, you want to put live traffic on this, to see how it behaves, to run some A/B testing, etc., etc. So of course, at this point, you're excited. You want to go quickly. You want to see results real quick. So you just go and take the quickest path, which is, let's take the model, embed it into the business app that needs that model, and let's be on our way, right? So a monolithic app with a model inside of it, deploy it to a virtual machine somewhere, and fine, okay? This is easy. We all know how to do this. It works. You can start putting live traffic on this. Life is great, okay? So who's there today? And come on, don't be shy. We've all been there. Okay, so a few people are there, and that's all right. At least you're in production, okay? And it's the only thing that matters. So if we look at how we're doing things here, infrastructure effort, pretty much zero, right? How much effort is running a VM? ML setup, pip install, whatever you need. CI/CD, come on, you don't need it. Building models, okay, that's what you actually do, or someone in your team does. Training, just run your training script. Deploying, predicting, just run your prediction script. And scaling, optimization, cost optimization, and security, later, yeah? Sounds familiar? Yes, I can hear you. Okay, so fine, and you keep doing that. And of course, after a few instances and a few models, problems starts to arise, right? Life is not that good anymore, because you keep doing that manual work of starting instances, deploying your app, debugging, etc., etc. So it's time-consuming. It's not what we like doing. And of course, the monolithic architecture is just painful, right? Because it means every time you update the model, every time you retrain the model, you have to deploy the app again. You can't share models. You can't scale them properly. I mean, same old, right? So a couple of options, of course, would be stop doing manual work. I'll talk in a minute about some tools that we provide to help you focus on the model itself and not managing virtual machines and different things. And of course, monolithic architecture can be at least Dockerized to solve deployment problems, and hopefully you can break it down into different pieces. Right? You can create a prediction service, so separate the business logic from the machine learning model, using model servers, or maybe building a specific API. Okay, so basic techniques we've all used for years, and they also apply for ML. So if you run on AWS and you want to make your life a little easier, we have those deep learning AMIs and deep learning containers that we maintain for popular frameworks, and you can just run them directly. Okay, so unless you really, really love building AMIs and containers, these are, I think, a good option. They're free to use. Okay, you just pay for the instance running them, but you don't pay for the AMI or the container. And they come in different flavors, and they're honestly quite easy to use. So I can show you maybe real quick how to do this. Okay, and that's a good option if you, let's say, if you need, for example, GPU instances for training and maybe prediction. Okay, honestly, okay, it's just me, but don't go and buy expensive GPUs that you will not use fully, and that could be out of date pretty quickly. Just, why don't you run this on the deep learning AMI? So let me show you how to do this. So this is how it goes. In the interest of time, I've prepared some of that stuff. But in a nutshell, you would just run an EC2 instance, passing the AMI ID for the deep learning AMI. Okay, here we're running a P32XL instance. It's a GPU instance. I'm grabbing a spot instance because I want to enjoy the nice spot savings. And I can tag my instance. And of course, I need to set a key pair and a security group and an IAM role. Okay, just like that. Okay, so this is all it takes. Starting an EC2 instance with their deep learning AMI. And then, of course, I want to connect to this. So I need my machine learning glasses. All right. Yep. You'll get there. Don't worry. Trust me. Okay, so this is the exact stuff that I run. Okay, and then and all this stuff is on GitLab. So I'll show you the link at the end. Okay, and so of course I do see my EC2 instance here. Here it is. Okay, that one, the last one. Okay, it's running. And I can open an SSH. Hopefully my command is still here. I don't have to type it. Yeah. Okay, so I can SSH to that instance and set up port redirections so that if I start, and that's probably still here, yes. If I start Jupyter on this EC2 instance, then I can just go and connect to it, okay, and pass the token here. Okay, here we go. And from now on, you know what to do, right? It's a Jupyter notebook, and I could clone my repos, and I could do anything that I want. Okay, and I can shut down this instance once I'm done. And you can pick the instance size that you like. I picked a GPU instance because that's typically something that's quite expensive if you want to buy it yourself. We have all kinds of instances, tiny ones, monster ones, so just pick the ones that you like best, okay? And that's it. So if you're a DevOps person and you need to set up Jupyter environments for your team and they have fancy hardware requirements, you can get this done in 5 minutes, okay? It's honestly one EC2 command to start the instance. And of course, you could use CloudFormation or Terraform if you wanted to do that. And then just SSH, and that's it, okay? And shut everything down once you're done. Nothing fancy. Okay, of course, I'm not gonna show you Docker containers because it's exactly what you'd expect. So we have a list of containers for training and prediction on TensorFlow and MXNet with different versions. So you can Docker pull and Docker run and do all that good stuff. Okay, so it's exactly the way, it works exactly the same way as you would work with Docker, except we maintain those containers. You don't have to do it. The versions in there are optimized to for best performance on EC2 instances. So it's just something you don't have to do, right? And if you want to grab the base container and add more stuff to it, okay, fine, do that. But save yourself the trouble of building all that stuff. You have more important work to do, I think. Okay? So that's one easy way to break out of the laptop, okay? Go to the cloud and go to the cloud and enjoy elastic machine learning infrastructure, okay? So that's super easy. You know how to do that stuff. So at some point, of course, scaling alert. So something happens in the team, in the company. More customers, more team members, more models, maybe more money from investors. Yes, okay, you have more work to do now. The thing is, now you have paying customers and you need to scale and you need to have a high availability and you need to have security. Okay, so all those things where you said, later, come on. Now they're a thing, okay, and they're a big thing. So I hope I don't have to convince you in 2019 that scaling up is a losing proposition. Okay, so a bigger server will work for a while. It's going to cost you more money. Are you sure you're actually using that infrastructure correctly? Scaling up, it might be an emergency way of solving short-term problems, but in the long term, scaling out is what you need to do. Okay. And of course, as you scale out, you keep increasing the number of instances. And so it would be silly to do manual work here. So only automation can save you. And again, this is kind of a DevOps conference, so I hope I don't have to convince you that infrastructure as code and CI/CD and all that good stuff is the only way to go, okay? And for machine learning, it's the same as everything else, all right? Don't let that stand in the way. It's not different. Okay, so what are your options? So the first options, of course, would be, hey, let's use virtual machines, right? Let's keep building EC2 clusters and EC2 endpoints and blah, blah, blah. And so sure, it's possible, but I want to know why. Okay, so if someone in the room is doing this at large scale, I want to know why you're not doing it another way. Okay, and I'm not being sarcastic here. I just want to understand. Because to me, unless you are automation gods, and of course, this is Ukraine, so you are automation gods, I know. But unless you truly are great at automation, you will have a lot of operational problems and you will have some unnecessary spend, okay? So if you want to do it, sure. But please at least use, CloudFormation, Terraform, automate everything, take everything down when you're done working with that infrastructure. You don't want to have clusters, GPU clusters sitting around doing nothing. If you're setting up distributed training on your clusters, it's not going to be fun, okay? Try it once and then send me a tweet saying, yeah, you're right, it was not fun. Prediction is the same. Please automate everything. And use auto-scaling, use load balancers, use all that good stuff again from EC2. But if you're doing this today, it's a bit of work, right? Even automating and running that stuff is a bit of work. And whatever you do, please use spot instances, okay? If you use EC2 today and the word spot doesn't ring a bell, you're probably spending 60 to 80% too much on EC2, okay? So when you go back to the office, look for EC2 spot and thank me, okay? Hey, I saved 80% on my EC2 bill, right? So if you do this, infrastructure effort is important, right? Because you're dealing with EC2 instances and subnets and VPCs and SSH keys and all that stuff, okay? ML setup is not that painful if you use the deep learning AMI. CI/CD will work the same. If you know how to deploy to EC2, fine. You can deploy models. Building and training is up to you. And deploying and scaling and optimizing and securing is up to you using all the EC2 features. Okay, so you have everything that you need to do the work, but it's a little bit unnecessary, if you ask me, right? But if you love IAM and VPC and KMS, please have fun with that. Option 2, Docker clusters, of course. And if you're already using Docker today, it makes, of course, a lot of sense, right? If you have Docker CI/CD setup, if you have Docker tooling setup, if your development flow is based on Docker, then it makes sense to deploy training containers and prediction containers to Docker as well, okay? And you put all your eggs in the same basket, and you know how to monitor that stuff and how to manage it, and it's fine. So when it comes to AWS, we have two services called ECS and EKS. Okay, so ECS is our own cluster manager, and EKS is based on Kubernetes, as I'm sure you know. So I don't want to argue on, oh, should you use ECS or should you use EKS? You know, Pepsi, Coke, McDonald's, Burger King, ECS, EKS, right? So I use both. I like both, just depends. So you can pretty much do the same thing. They're flexible. You can mix instance types. You can have CPU instances. You can have GPU instances. You can define constraints on where to place containers, etc., etc. And we provide AMIs for both. So use those. They will save you more time. Again, use the one that you like best, the one that helps you work fast. I think a more important question is, should we have one cluster or many clusters? So for development, I would say dev and test, it's important to be able to create on-demand clusters. Yeah. If each developer should be able to get their own cluster and break it and restart it, etc., etc. So automation, again, is important. For production, I find that a lot of customers run a large single cluster because it's, again, it's easier to keep an eye on that. It's easier to scale. It's easier to monitor. And it just gives you more flexibility, right? If you have a 50 or 60 node cluster, you have plenty of scheduling opportunities. And I find a lot of customers do that. Still, ECS and EKS do need some ops work. They're instance-based, and this is not a fully managed proposition. So you need to set things up, you know, and of course, if you're already doing Docker today, you probably know how to do that, you know, setting up services on ECS and pods and deployments on EKS, service discovery, etc., etc. Okay, and so not hands-free, not hands-off. And sometimes people tell me, yeah, I don't really care because, you know, I'm doing data science or I'm doing machine learning and someone else is doing that work. Well, okay, again, a lot of those someone else's are probably in the room today, right? And you know it's extra work and you're getting paid for that. And what if, you know, you spent your precious time and your boss spent their precious money on something else, right? Just a thought. So in the interest of time, I could show you ECS and EKS. So I flipped a coin last night and I'm going to show you EKS. Hope it's okay. But again, you will get the scripts for EKS as well. Okay, so let's take a look at that. So I created an EKS cluster. Let me show you the, I can close this one now. I can shut this one down. All right, EKS. Okay, here we go. So again, I'm using the AWS command line, but you can use APIs and you can use Terraform and you can use CloudFormation and anything else. Okay, so I'm just creating an EKS cluster here with the first group of workers. Here I'm creating a group called CPU workers with 3 nodes, C5 instances. And then I add a second group with GPU workers, P2XL, etc., etc. Okay, EKS CTL is the command line tool that we use to manage EKS clusters. Okay, so you run that stuff, you wait for a few minutes, and you have a cluster. Okay, so if you go to the AWS console, you can see that stuff. Okay, but I guess we don't really want to see the console. We want to use tools that we know. Okay, so we can see, all right, show me. Okay, show me some groups, show me some nodes, what's happening there. Okay, so the cluster is up with all those instances, and again, the only thing that it took was just a couple of commands or a simple, let's say, a simple CloudFormation script. Okay, and then, okay, I want to run some stuff here. So let's say first, you know, I want to run the NVIDIA SMI tool, which just lists the GPUs present on the cluster. Well, I would just apply this pod with the NVIDIA CUDA image and just run the NVIDIA SMI tool. Okay, nothing fancy. And then, of course, I could see. So I've done this before to save some time. Yes, okay. So this container has run, and this is the output. And so this one has run, obviously, on a CPU instance, and it did not find, oh, no, GPU instance, sorry. And it did find that K80 GPU, okay? And in the same way, I could start training something. Okay, so I could start a training pod using using one of the deep learning containers. Okay, so this is actually one of ours. And I'm cloning Keras inside of there, and I'm running a simple example to train a convolutional network on the MNIST dataset. Okay, and I say, hey, give me a GPU, so this will make sure that this container runs on a GPU instance. Okay, because remember, I've got both in the cluster. And of course, I could look at those logs again. Okay, run that stuff this morning. Okay, so I see the training log, and it's all fine, right? So this is EKS in a nutshell. Create the cluster. All the control plane. Where's EKS? Here it is. All the control plane is managed. Okay, and if we look at instances. Okay, I see my workers here. Okay, so I see my CPU instances, and I see my GPU instances. So these are visible. The control plane is managed by the service itself. So you don't have to manage all that stuff in Kubernetes. That's a little bit tricky to manage. Let's admit it. Okay. So you can do this stuff. It's not complicated. You can run either ECS or EKS. Setting things up is quite easy, and then you use the tools that you know and the containers that you know to get things going. Okay, and of course you could run Jupyter notebooks in there as well if you wanted. I mean, you know this stuff better than I do, right? Managing Docker clusters. So if we look at the scorecard, infrastructure effort is not as bad, okay, because we use command line tools, Docker tools, to provision everything, and like I said, you know, the scheduling and the control plane, all that stuff is taken care of automatically. So it's not as difficult as setting up Kubernetes on EC2. ML setup is not very complicated. If you use, again, the deep learning containers, it's okay. CI/CD is fine if you know how to deploy models. If you know how to deploy containers, well, there you go, no change. Again, building models, training models, deploying models is your responsibility, but you can use, again, the Docker tools, which are pretty good, and save some pain here. Scaling, cost optimization, and security, again, is very much your responsibility, and you can use either the Docker tools or the EC2 tools to do that. Okay. So a little bit better, and again, when it comes to scaling, okay, that's definitely a more interesting proposition than just managing EC2. But there's another one. Okay, the last option I want to talk about. If machine learning is really central to your business, if you have lots of models, you know, if you start training hundreds of models, maybe thousands of models every day, and it sounds like a crazy number, okay? Like, no, come on, no one really trains thousands of models every day. And, well, you'll be surprised, right? Because you want to try different algos, you want to try different combinations of parameters. Maybe you want to do hyper-parameter optimization, looking for the top performing model, and very quickly, before you know it, you're going to be training hundreds and hundreds of models every day. So keeping track of all that stuff, you know, with Docker clusters, it needs a bit of work. You know, where is the training log? What were the parameters for this specific training job? Which is the top performing job I trained today, etc. You know, as you start scaling your machine learning process, you realize, okay, you need more tooling to be efficient. So of course you can build it yourself, or you can try the fully managed option, and this is a service called Amazon Sagemaker. And Sagemaker is basically a modular service
that lets you go from experimentation, so Jupyter notebooks, all the way to production, so deploying models, with a single service and a single set of APIs. Okay, so when I say modular, I mean you don't have to go from A to Z, right? You can pick whatever you need in there. Let's say if your problem is training at scale, and then you have to deploy on-premise because that's what your customer wants, that's all right. You can train in SageMaker, grab the model in Amazon S3 and deploy it elsewhere. Okay, or maybe even test it on your laptop. If you want to do the reverse, if you have an existing model and your problem is more deploying at scale to the cloud, that's fine. You can put your model in S3, ask SageMaker to deploy it. Okay, so enter anywhere, exit anywhere. You don't have to do all of it. And it's quite a popular service. It's being used by all kinds of companies, big ones, small ones, enterprise, startups, all kinds of verticals. The only one I'm not too sure about is Tinder, which nobody uses, right? And of course, I don't really see the machine learning use case in there. So I'm skeptical. Seriously, what are your options now? If you want to train on SageMaker, you can train in 3 ways. You can use built-in algorithms, and this is a really good option if you don't have a lot of machine learning skills, okay? If you don't want to write machine learning code. You need a clustering algo, you need linear regression at scale, you need image classification, that kind of stuff. So you can just grab one of those algos off the shelf, set some parameters, and train. Okay? So we have 17 algos, no machine learning needed, great option to get started. Now, if you have existing machine learning code for one of those frameworks, TensorFlow, PyTorch, scikit-learn, etc., then you can take that code and with absolute minimal changes, which I don't have time to explain today, but it's really, really just a few lines of code, you can run them on those built-in frameworks on SageMaker. Okay, so take your TensorFlow code, your Keras code, whatever, throw it at SageMaker, train at scale, deploy at scale. And the last option is, what if you have something else? Let's say you're using R or C++ or another environment. Well, you can build your own training and prediction container, because of course all this stuff is also based on containers, and push that to AWS and train and deploy on SageMaker. Okay, so you can run pretty much any workload here. Everything happens through a specific SDK in Python, which we call the Sagemaker SDK, and it's a high-level SDK. If you're familiar with the AWS APIs, the service-level APIs, this is much, much higher level, so you work with algos and models and training jobs, and it's very little code. I'll show you a quick example in a few minutes, but this is just a very nice and simple SDK. You can learn it in just a few hours to get your training and deployment jobs going. Okay, there's also a version for Spark if you want to integrate SageMaker with Spark. And of course, we also have service-level APIs for SageMaker, but these are lower level and probably the ones you want to use for scripting, automation, etc., etc. Okay. So let's look at a quick example. How would you train and deploy with TensorFlow? Okay. So the 30-second story is you put your data in S3. Okay. You can now also put it in EFS or FSX for Lustre. That's a recent feature. If you need super high performance training, you can use EFS or Lustre. But I would say for most people, S3 is just fine and easier to set up. So put your data set in S3, import the SageMaker SDK, and in this case, we would use the TensorFlow object, okay, to set up a TensorFlow training job. The first parameter is your TensorFlow script. Okay, in this case, it's a Keras script. Keras is part of TensorFlow anyway. You say, hey, please train on one C5-2XL instance. And you pass some parameters to your script. You call fit, passing the location of the data in S3, and that will train, okay? So it will fire up that C5 instance, pull the TensorFlow container, train the model, save the model to S3, and then shut down that C5 instance automatically. So it's completely on demand, it's fully managed, you never have to worry about starting, stopping stuff. It's done automatically by the SDK. And then if you want to deploy to an HTTPS endpoint, you say, hey, please deploy to T3XL, and this will automatically create that instance, pull the container, and load your model, and you can start serving predictions on that HTTPS endpoint. Okay, so you can use the predict API in the SDK, but of course you can use it. You can use any language to HTTP post to the endpoint. That's it. Okay, so when I say you can learn this stuff in 2 hours, I'm not really not lying. Okay. Now imagine you want to scale things up. Okay, this is a tiny model on a small instance. Okay, so now you want to move to my crazy CNN.py, and you need 64 GPUs to train it, and you need 16 load-balanced instances to serve predictions. That's it. Okay. I can do this all day, right? The only change is just give me more instances, just give me bigger instances. Okay, that's it. And this will create automatically the training cluster with those P3 instances, and it will create the multi-AZ load balanced endpoint backed by 16 instances in this case, etc., etc. Okay? So that's a great way if you want to, even your data scientists could do this directly, right? They don't really need you anymore, which is great because now you can focus on more important stuff than managing training clusters. So that's what this SDK is for, okay? Even if you don't know anything about infrastructure and no VPCs, no subnets, no nothing, just call this and train and deploy. So I can show you actual code really quickly. I'm not going to run the notebook, so I don't have time for it, but just to prove my point. So here I'm using one of those managed notebooks, okay, which is part of Sagemaker. Okay, so I'm using this fashion MNIST dataset, which you've probably seen. I'm training an image classifier. So download the dataset, put it in S3, okay, and that's pretty much the code you just saw, right? Pass that script to the TensorFlow object in the Sagemaker SDK. I can even use spot instances to save even more money. Call fit to train. Okay, and I see my training process here. Okay, and thanks to spot, I saved 64.5%, which is always nice. And then I can deploy. Okay, one line of code, and then I can predict, right? And I might even try to run this. Yes. Okay, so take 10 images from the data set, post them to the endpoint, and compare the labels to the predicted labels. Okay, so anyone can do this. Anyone can do this. Like, even data scientists can do this, right? I love them. Just making sure. So there you go, right? And you could be using a ton of GPUs and a large endpoint. It wouldn't be different, right? So how many lines of code did we write to do this? Right? Imagine how much work you would need to do this on the Docker cluster, and imagine how much work you would need to do this on EC2. Okay? So it's worth trying. So, oops. Yeah. So in this case, infrastructure effort, 0. ML setup, pretty much 0, because again, all those algos and all those frameworks are built in. CI/CD is probably where you will need a bit of work, because you would use probably the SDK to automate things. You can use step functions, AWS step functions as well. It supports SageMaker very nicely, but it's probably the area where you would need a bit of work. You can use 17 built-in algos. Training at any scale is 2 lines of code. Deploying at any scale is 1 line of code. And you can use Spot, and you can use auto-scaling, and security is integrated. So if you need KMS encryption for the training instances, just say, okay, encrypt, and that's it. Okay, so it's nice. So my personal opinion, EC2 is fine to get started. Okay, small scale, experimenting, fine. But don't scale on EC2 unless you are automation gods, okay, and you actually enjoy spending the time doing it. ECS and EKS make a lot of sense if you're already using Docker, so why not? But if you're not a Docker shop today, if you're not deploying to Docker, I would think twice, because Docker is a general purpose platform. It's not a machine learning platform. So if you need lots of high-level machine learning features, like hyperparameter tuning and all that stuff, you will end up building it yourself. And I don't think it's a great idea. And Sagemaker, again, is easy to learn, zero infrastructure work, and it has a lot of high-level machine learning features that I don't have time to cover today. But, and obviously more are coming at reInvent. So keep an eye on that. And if, again, machine learning is central to what you do, you will find that you save a ton of time doing this. So my conclusion is, don't worry too much. I mean, you guys are reasonable people. Whatever you do today is probably fine. Don't over-engineer. Scale linearly until you have to make that jump, and then just make that jump. Pay attention to total cost of ownership. Okay, don't over-provision. Don't spend your money in a silly fashion. And remember, when you do machine learning, models and data matters. Right, matter, not infrastructure. We don't care about infrastructure. So if you have to scale, just smash and rebuild, which is what the cloud is about. Okay, take big, bold steps. Just smash it on Monday and run it again on Tuesday, and it's all good. Okay, and focus on understanding data and building models. And of course, you can mix and match if it makes sense. So like I said, you can train on SageMaker and deploy on-premise or deploy on Docker or whatever, okay? Find the combination that works best and write your own story. And just make sure you optimize your workloads and your budget and your time. So how do you get started? So lots of stuff here. So the first thing I want to say is we actually have another event, an AWS event in Kyiv very soon, October 14th. So it's a physical event. Some of my colleagues will be there, and it's a full week of sessions. And if you have AWS questions, just go there and ask them. You can register at this URL. It's completely free. We also have on the October 17th, we have an online conference called Innovate, which is dedicated to ML and AI. So 20 sessions, again, completely free. And you can see the agenda online, and it's a lot of good stuff. And of course, all the URLs to get you started, including links to those notebooks that I saw, that I showed you. So thank you very much. We're going to take a look at questions. I think you're going to show the questions on screen. If you want to stay in touch, I'm happy to connect on LinkedIn, and my messages are open on Twitter as well. So if you have questions next week, next month, just ping me, and I'll try to answer to everyone. Okay, thanks again. Thank you very much for having me today. Thank you. So are we doing questions? Oh, okay. Oh, yeah. Okay, wow. Oh, okay. So I need my Q&A glasses now. All right. Okay, what ML framework is the best for creating a proof of concept fast? Oh, that's a very good question. So I'll give you my personal preference, okay? My personal preference is Keras. I think Keras is a high-level API on top of TensorFlow and MXNet, actually, but it's very, very easy to work with Keras. It's beginner-friendly. The documentation is great. You'll find lots of examples. The Keras blog is very good. So Keras is very interesting. If you want another option, then MXNet has a toolkit called Gluon, which again is a high-level API, very flexible, and it's equally good. Okay, so Keras, Gluon for prototyping are excellent. So there's a question, can SageMaker do request batching for efficient inference? So yes, when you can actually send, so two answers actually. So first, you can do batch processing with SageMaker, okay? You don't have to deploy to an endpoint. You can actually say, hey, here's data in S3 to predict. Just predict the whole thing in batch mode, and that's fine. We call it batch transform, okay? So if batch processing is what you need, it's supported. If you want to batch samples and predict multiple samples in one go, absolutely. On the top of my head, I don't remember the maximum request size for prediction on SageMaker, but it's megabytes. So you can absolutely pass 100 samples at a time if you want to batch them. What is the distributed training implementation behind SageMaker? So it depends. So built-in algos are implemented with Apache MXNet. So we use the distributed framework that's part of MXNet. And of course, if you use TensorFlow or if you use the built-in frameworks, then we use whatever is available there. So for TensorFlow, there's the built-in mode, which is called parameter server, which is fine. Doesn't scale to the moon, but it's fine. We support it. And you can also use Horovod if you have large-scale training jobs. We support Horovod, and that will absolutely scale to the moon. So different libraries will support their native ways of doing things. What else can I answer quickly? Okay, what approaches do you use for downscaling your resources when they're not required in order to reduce bills in case of using Docker? So that's a very good question, actually. And when I said Docker, ECS, EKS are instance-based, it's kind of what I meant, right? So you start with a cluster of X nodes, and then you have to scale up and down. So of course, as always in AWS, you would set up CloudWatch alerts. Okay, CloudWatch is our monitoring service. I'm sure you've heard about it. So you would set alerts on cluster usage, container usage, etc. And you would trigger basically auto-scaling on the clusters, okay, up or down. But it's stuff that you have to manage, and it works. It's super solid, but you need to find the right thresholds. You need to find the right timings. There's a bit of tweaking, okay. So on SageMaker, it's not needed. You don't need to do that stuff. My favorite question. What are the advantages of AWS ML services compared to competitors? I have no idea, right? I don't use the competitors, so you know more than I do. So try them, and then send me tweets, okay? And if they do some stuff better than we do, we'll fix it, okay? And if we're better, you can tell me as well, right? I actually enjoy positive feedback, right? Negative feedback is more useful, but every now and then, oh, I tried this and it's just as good as you said. Okay, you can send me that stuff. All right, I don't want to run for too long. The other questions are probably a little bit too long to answer. So again, if you want to know more, please go to the Loft next week. We'll have staff there all week, and they can dive deeper into your questions and your projects. And if you want to have the big picture, and if you want to learn everything there is to know about AI and ML services on AWS, again, the Innovate conference is where you need to go. I mean, we have tens of thousands of people who have registered already. So, right, looks like the agenda is interesting. Okay, we're completely out of time. So thank you again for inviting me. It's been a pleasure. I hope you have a great day. And again, get in touch later on if you have questions. Okay, thank you so much.